Oxygen is the invisible gas that surrounds us, filling every breath we take, the essential element we breathe in with every gasp. We hardly think about it, yet it's always there, providing the vital force that keeps us alive. Without oxygen, humans wouldn't last more than a few minutes. Our cells need it to function properly, to turn food into energy, powering every action and thought. The air we breathe is about 21% oxygen, a delicate balance that has allowed life to thrive on Earth for millions of years. But what if that balance were to shift? What if oxygen levels were to change dramatically? Our planet has seen dramatic swings in oxygen levels throughout its long history, affecting all forms of life. Hundreds of millions of years ago, oxygen levels were much lower than they are today, creating a vastly different environment. Over time, they rose, allowing for the evolution of complex life, including us. But these levels haven't remained constant throughout history. There have been peaks and valleys, periods of high oxygen and times when it was scarce, times of abundance and times of scarcity. These fluctuations have had profound consequences for life on Earth, driving evolution and extinction, shaping the course of evolution and influencing the very air we breathe today. The story of oxygen is the story of life itself. Imagine a world with less oxygen, where the very air we breathe is no longer abundant. Every breath would feel shallower, less satisfying, as if we were constantly gasping for air. The air would be thin, leaving us perpetually short of breath and yearning for more. What would happen to our planet, to the intricate web of life, if oxygen levels were to decrease significantly? The consequences would be far-reaching and dramatic, affecting every aspect of life as we know it. One of the most immediate effects would be on our own bodies, our very survival at stake. With less oxygen available, our cells wouldn't function as efficiently, leading to a cascade of health issues. We'd experience shortness of breath, constant fatigue, and dizziness, making everyday tasks a struggle. Simple activities would become exhausting, and our quality of life would diminish. It would be like living at high altitude all the time, where the air is thin and our bodies are constantly struggling to adapt. Our bodies would be in a constant state of stress, trying to cope with the thinner air. But the effects wouldn't stop there. The entire planet would feel the impact. A decrease in oxygen would impact every corner of our planet, altering ecosystems and weather patterns. Plants, the very lungs of our planet, would struggle to produce the oxygen we need. Forests would shrink and biodiversity would suffer. The air would become heavy with carbon dioxide, exacerbating climate change and pollution. The delicate balance of our atmosphere would be disrupted, leading to unpredictable and severe weather events. The potentially catastrophic consequences for all life on Earth would be unavoidable, altering the course of our future. A world with less oxygen is inextricably linked to the looming threat of climate change. The air we breathe is becoming increasingly polluted, and the consequences are dire. As we pump more and more carbon dioxide into the atmosphere, we're not just warming the planet, we're fundamentally changing the air quality. We're also altering the very composition of the air we breathe, making it harder for people, especially those with respiratory issues, to live healthy lives. Carbon dioxide is a greenhouse gas, trapping heat and driving global warming. This warming effect leads to more extreme weather patterns, affecting millions, but it's also a key player in the oxygen cycle. Plants rely on carbon dioxide for photosynthesis, a process that produces the oxygen we need to survive. Plants use carbon dioxide during photosynthesis to create oxygen. This delicate balance is crucial for maintaining life on Earth. As we increase carbon dioxide levels, we're also disrupting this delicate balance. Deforestation and pollution are making it harder for plants to thrive. The oceans, vast reservoirs of life, are also feeling the suffocating grip of climate change. Marine ecosystems are being altered in unprecedented ways. As the planet warms, ocean waters absorb some of the excess carbon dioxide. This absorption changes the chemistry of the water. This might seem like a good thing, but it comes at a cost. The increased carbon dioxide levels lead to ocean acidification. When carbon dioxide dissolves in water, it forms carbonic acid, making the water more acidic. This change in pH levels is harmful to marine life. This process, known as ocean acidification, is a serious threat to marine life, particularly to creatures with shells and skeletons made of calcium carbonate, like corals and shellfish. These organisms struggle to survive in more acidic conditions, leading to weakened shells and bleached corals, which disrupts the entire marine ecosystem. Imagine diving into the ocean depths, only to find yourself surrounded by silence, the vibrant coral reefs reduced to bleached skeletons. This is the grim reality of ocean deoxygenation, a growing problem driven by climate change and pollution. As ocean waters warm, they hold less dissolved oxygen. This, coupled with an influx of nutrients from agricultural runoff and sewage, creates the perfect storm for oxygen depletion. Fish, crabs and other marine creatures rely on dissolved oxygen to breathe. As oxygen levels plummet, they become stressed and vulnerable to disease. In extreme cases, vast areas of the ocean can become dead zones devoid of most life. These dead zones are expanding, suffocating marine ecosystems and threatening the livelihoods of millions of people who depend on the ocean for food and income. To understand the potential consequences of changing oxygen levels, we can look back at Earth's history. Billions of years ago, our planet's atmosphere was a toxic soup of gases, devoid of the oxygen we need to survive. The first life forms were simple, single-celled organisms that thrived in this oxygen-free environment, but everything changed with the evolution of photosynthesis. Cyanobacteria, also known as blue-green algae, were the pioneers of photosynthesis. These microscopic organisms developed the remarkable ability to harness sunlight to convert carbon dioxide and water into energy, releasing oxygen as a byproduct. This oxygen revolution transformed our planet, paving the way for the evolution of more complex life forms, and ultimately leading to the oxygen-rich atmosphere we enjoy today. Section 6. A world on fire, the perils of too much oxygen. While too little oxygen poses a serious threat to life, too much oxygen can be just as dangerous. Imagine a world where wildfires rage out of control, fueled by an atmosphere supercharged with oxygen. This isn't just the stuff of science fiction. It's a scenario that played out millions of years ago during the Carboniferous period. During the Carboniferous, oxygen levels soared to unprecedented levels, reaching an estimated 35%. This oxygen-rich atmosphere allowed insects to grow to enormous sizes. Dragonflies with wingspans of over 2 feet soared through the air, and millipedes grew to lengths of over 6 feet. But this abundance of oxygen came at a price. Wildfires were frequent and intense, fueled by the readily available oxygen. These fires shaped the landscape, leaving behind vast deposits of charcoal that we now burn as fossil fuels. Section 7. Giant bugs and oxygen's ancient reign. The reign of giant insects during the Carboniferous period is a testament to the profound influence of oxygen on life's evolution. With more oxygen available, insects which breathe through a network of tubes called trachea could grow to enormous sizes. These trachea are less efficient than lungs at delivering oxygen to tissues, so larger insects require higher oxygen levels to survive. As oxygen levels declined after the Carboniferous, so did the size of insects. Today, with oxygen levels hovering around 21%, insects are much smaller, their size limited by the availability of this vital gas. The era of giant bugs may be long gone, but it serves as a reminder of the profound impact that oxygen can have on the evolution of life on Earth. Section 8. Breathing easy in space, NASA's quest for oxygen. Venturing beyond Earth's atmosphere presents a unique challenge: how to breathe in the airless void of space. For astronauts to explore the cosmos, we need to find ways to create breathable environments in the harsh conditions of space. NASA has been at the forefront of this challenge, developing innovative technologies to generate oxygen for astronauts on long-duration missions. One promising technology is the oxygen generation system aboard the International Space Station. The OGS uses electrolysis to split water molecules into their constituent atoms, hydrogen and oxygen. The oxygen is then released into the station's atmosphere, providing breathable air for the crew. This technology is not only essential for life support in space, but it also has the potential to be used in future habitats on the Moon and Mars. Section 9. Safeguarding our breathable planet. Oxygen is the breath of life, a precious and finite resource that sustains us all. As we grapple with the challenges of climate change and environmental degradation, it's more important than ever to understand the delicate balance of our planet's atmosphere. The air we breathe is a common heritage, and its preservation is a shared responsibility. By reducing our reliance on fossil fuels, protecting our forests, and embracing sustainable practices, we can help to ensure that future generations inherit a planet with clean air and a stable climate. The future of our planet and the very air we breathe depends on the choices we make today. Let's choose wisely for the sake of ourselves and all life on Earth.